All right. Well, happy Wednesday again. Happy hump day. I explained that last week what hump day means, right? That's if you thought the week was like a hump of a camel, this is the middle, this is the top of the hump. That's why they call it hump day. All right. So we had a warm up. You had a couple of pictures and you were asked to, what do you notice? What do you wonder type question, right? And again, what do you notice? What do you wonder? I had this problem with first period and I purposely didn't look at your answers while you were doing them because I want to read them as fresh. But first period, their geometry, so they had different pictures, but their notice and their wonderings are very, 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 how do I say, not specific. So like I had pictures of two triangles and they had side lengths and they said, I noticed two triangles. I noticed there are numbers like there. And I would say, no, you can't give me descriptions like that. I need more specific descriptions. Like if we were outside, right? If we were at school, let's imagine, I know that was almost a year ago that we were at school and someone's bugging you. And then you go to the assistant principal that's out there or principal, whoever's out there, you go to somebody, an adult, and you're like, Mr., Miss, that kid's bugging me over there. And then they say, which one? And if you say, oh, the one with the nose over there, that's not enough. That's not specific. And they will tell you, you got to be a little more specific. They all have noses over there. Oh, okay. I'm sorry. The one with two eyes. Okay. Can you be a little more specific? They have clothes on. They have two legs, two arms. They have hair and they have 10 fingers. Well, that describes most of the people over there. Can you be, that's the kind of answers I was getting. So let me see if that's the kind of answers I got here. And yes, I paused it, so you can't go in and change it and go, oh my God, that was me. I paused it. You can't change your answer. So this first picture, okay, what do you notice? What do you wonder about the graph shown? So here's what I see. I noticed the graph was decreasing, then it maintained, then it increased. I also see that the line is a wiggly, have many points. Okay. Wiggly, I like that. It's not an official math term, but we should make that. We should try to get into that meeting of old math people. Remember I tell you that old math people of the world get together and like, okay, we're having our annual math meeting to talk about math stuff. We should try to sneak in there and try to sneak in Wiggly. Wiggly is an official. I declare that we should make Wiggly a new math term, put in all the textbooks. Oh, I don't like it. That's too fun. That Wiggly's too fun of a word. I don't know. We'll try. But I like this. The graph was decreasing and then it maintained and then it increased. So good. We have some specific words in here. I'm proud of. Good job. Good job. So I noticed the graph almost looks like a quadratic graph, but this one used squa. They didn't finish. I pressed pause, I think, in the middle of their word. But this one is SQU, squa. What were they trying to say? I guess we'll never know. All right, next person said, I noticed that the line is more curvy than usual graphs. I wonder what is being graphed here. Someone just put a question mark. No, you can't put a question mark. You can see things here. You can tell me any description. You can't put a question mark. You look at this and just say, you can say, hey, it kind of looks like a W. There are no wrong answers except the question mark. I guess there are wrong answers. You notice something, even if it's nothing mathy. Doesn't have to be the thing you notice. Doesn't have to be mathy. Just what do you notice? What do you notice? Okay, it has a resemblance of a roller coaster ride where you are at the top and then drop down, then go back up. Okay. What is this? What is this? Ax to the n is n ax to the n minus 1, a to the first minus 1, a to the 0 equals 1. Wait a second. You came up with an equation for this? But you did x to the n? So what is this? Is this what Photomath gave you? Okay, I don't know what that description is. Oh, this is calculus. You just gave me the definition of the shortcut for a derivative. Ax to the n is n ax to the n minus 1. Yeah, that's the shortcut for a derivative. So somebody did some calculus in here. I don't know I don't know where you got that from. Would you tell me, please, in the chat? Where'd you get this from? That's curious. That's the shortcut for the derivative of calculus. Is somebody in your house doing calculus and you just wrote that down? Is this what Photomath told you? Because Mr. Choi has been sharing with me a lot of his answers of his students. And they're doing a lot of calculus in his Algebra 2 class. Yeah, I told them my students don't do that. Sorry, I had something in my throat. It starts from up to low, to a little bit low, then up. I think it's a roller coaster. What I believe this graph is showing is that it starts off from a big number, but then it starts decreasing to a lower number. It also begins to increase once it gets to the points 1, -1. I question if this graph is showing some sort of prices for something. Maybe maybe for a stock price or something. I noticed that the line increases, then decreases. It's squiggly. So we got wiggly, and now we got squiggly. That's another fun word we can take to the math meeting. It's all cracked out. Why though? It's all cracked out. Why though? Okay. Why do you mean it's all cracked out? What's so cracked out about it? Give me specifics. I noticed that it has a very fast and steep decline at first, and then it tries to go back up, but declines a little more and then increases very rapidly. I wonder how this graph could be shown in a real video and how it could be modeled. Very good, very good. So you're describing the different pieces, because there's different pieces happening here, right? I think that's what the last person meant. It was all cracked out. Can't make up its mind, up or down. What are you doing? That's what I'm guessing. That's what all cracked out means. I notice that the graph has high and low points. I wonder why. What are the points exactly? I noticed that the graph is a squiggly line. There you go, squiggly again. And I noticed it was going down, but then it went up at the end. I wonder why the graph does not have a starting point. Why it starts with an arrow and ends with an arrow. Ooh, that's a great question. So now we notice the up and down nature of this, the cracked out nature of this. Then we also notice, and we're going to talk about this, that's great. It's like I put this person in there. What's happening at the ends, right? What's happening at the ends? Why are there arrows? Why are there no starting points? What I noticed about the graph is that it starts really high, then goes really low. All the way to negatives. After it slightly increases and then boosts all the way, it reminds me of the boosters or thrusters of a spaceship when it's trying to land. I question how the force can drop towards the negatives. How can we have negative force? So if you're thinking if this is force, so this measuring force, how can we get into the negatives if that's what it's measuring? Good question. So this person gave a backstory to it, gave a context. I like that. So what the things we did last week did work for somebody. I noticed that the shape or line is going up and down, and I wonder why it is like that figure. Yeah, why is it doing that? It seems that something is being measured and it keeps going up and down. I can predict that an object maybe like a roller coaster went down, right? When it hits 2, it's making its way up, then shows that it's doing uphill, downhill. Graph decreases and after increases. Good job. I noticed the graph isn't stable, and I wonder if it's something like hiking or on a bicycle since it's going up and down. I noticed that in the graph, the line is curved. Ooh, see, he used the actual math term. Yes, that's the actual math term, curved. But I like wiggly and squiggly too. Same thing, right? I wonder why the line is like that and what equation is used to make a line be like that. We will be talking about what kinds of equations that we have. Okay, I notice that the graph starts from a high point and then it starts going down and then up a little, then down a little as it goes up again, like how it was from the beginning. I noticed that then they stopped. What I notice is that the graph line goes up and down. What I wonder about the graph is what information makes the graph line go up and down. And then we have more. I'll read them. There's only 3 more. At first, the graph decreases, then it starts to increase. It decreases a little after increasing, but then increases once again. You guys are using a lot of these correct words. I like that you're noticing these different things. I notice that the graph has 2 low points and 1 high point. Look at that. So you notice that even though this goes on forever, really high, and this goes on forever, really high, you notice that there are 2 low points and 1 high point. These are particular things we are going to talk about. So you guys have noticed everything. You've noticed that decreasing, increasing, decreasing, increasing. That what's happening at the end of the graph. And then locally, just right here, not that forever, but just locally here, you notice there's two lows and a high. And then there's a point where it changes from decreasing to increasing, increasing to decreasing, decreasing to increasing. And if you were that person that was doing calculus earlier in here, if you were looking for those points where it changes from decreasing to increasing, that's where the derivative is 0. So when you take calculus, you're going to hear that and you're going to go, oh, I heard that in algebra 2. I remember. Yeah. Set your derivative equal to 0 and you'll find that point, and that point. One low point is lower than the other low point as well. I notice that the graph is going down and up, and it isn't just linear. I wonder what the graph represents. Good. These are all very good, except for the question mark. You should not have a question mark here. Just give me any description you give me is correct. Any description you give me is correct, especially on these warm-ups. There's no incorrect. So now the next one is this one. So let's see if we see anything different. Notice the graph has different shape. It's wiggly. Ooh, wiggly again. Oh, another question mark. This person gave a question mark twice. Okay, you're wondering what's going on. So just tell me that. Don't just put a question mark. What math will you learn your senior year? It's up to you. You can do pre-calc. You can take pre-calc over the summer and do calculus. You can take stats over the summer and then take AP stats. You can take stats next year. It's up to you. You can take financial math. I think there's a financial math. This one looks like if you were to live on a hill and had to drive down until you reach the bottom. It goes down, then up, then down. It could be a car going down, up, then down. I wonder where the starting point starts. So again, there's no starting point, right? Look at the end. There's just two arrows. I notice that the graph goes down and up. So, okay, so you guys are noticing the same thing. It's like a slide. Why though? Okay. No one said it's all cracked out this time. I notice the graph has one high point and one low point. So they're looking at these local maximum and minimums. Good, good. Because this is a high point because this goes on forever. So you can say, well, the high goes all the way to the top and this one goes all the way to the bottom. But locally, or in this picture, we can see there's a local high and a local low. We'll talk about those. All right, good job, good job. So give me 1 second. I got to set something up. Just give me 1 second. Okay, so now, what does this all mean? Why am I showing you graphs? Why were we looking at graphs last week? I think that helped a lot of you be able to look at stuff now and notice different things that are happening in a graph, not just look at this and go, ugh, that's a graph. I hate graphing. So we're going to start looking at graphing polynomials, and we're going to start thinking about ideas of little pieces of them, okay? So we're not going to just, because I know we can just get a graphing calculator. I mean, if I know you can just do this. Oh, this isn't working. What's going on? There we go. You can just get a graphing calculator, turn it on, and then hit this y equals in the corner, right? Hit that y equals and then type in your equation. And then if you type in your equation, x to the third minus 8, and you hit enter, and you hit graph, it'll graph it for you, right? And then you can do all kinds of things with this graph. I don't know why it's not showing the x and y axis, but you can change this and you can graph it. So I get it. Yes, you can graph on a graphing calculator, but it's nice to look at different pieces and understand what is this? What's happening at both ends? What's happening locally, what we call locally? Like, is there any highs or lows? When is it decreasing? What intervals is it decreasing? What intervals is it increasing? And that kind of stuff. Okay, when is it hitting the x-axis? Okay, how do we find those? When is it hitting the y-axis? How do we find those? That kind of stuff. Okay, so before we do that, just like we always do when we start something new, go to Schoology, okay? And if you look at our course, and you go to week 8, that's what we are in now, go to week 8, and you'll see Graphing Polynomial Functions notes. Those are the notes we're going to be using for the next week or so. The reason it looks like an assignment, again, you do not turn in your notes. You do not turn in your notes. But mister, it says due Wednesday, March 3rd. Yes, the only reason it says that is because I have to put your notes in here as an assignment. So that way you can use Kami. I know a lot of you like to use Kami, so I have to do that as an assignment. It's the only way I can get this in here as an assignment. So if you are on Google Chrome, you will see right here next to view, it'll say open with Kami. Doesn't show it here because this is my iPad. For some reason, it doesn't work like that on the iPad. And so that's, or if you just want to click on this and then you have this open in a tab, there's the notes. This we're going to talk about. So if you look at the notes, we're going to talk about polynomial functions, some examples, something called parent functions, end behavior, turning points, and all that stuff. So we're going to be talking about that. If you don't have a graphing calculator like this, if you don't have a graphing calculator, because you are going to need a calculator so you can look at these graphs, right? You can use Desmos. You can go to desmos.com. You don't go to student.desmos. If you go to desmos.com, it's a graphing calculator. I love it. So you can go there and you can graph any graph just like you would on a graphing calculator. Okay? So I'm going to give you a minute to go ahead and print this out. I know some of you print this out. Some of you open this up. Get this opened up. And then we'll get started and start taking notes. Okay? Any questions before? No? Okay, so I'll give you a minute. I'll give you 2 minutes to go ahead and get your notes all straight. Because I know when we have new notes, a lot of you are like, Mister, give me a minute to get this together. Some of you print it out. Some of you, again, some of you take it to your friends, which is awesome. Some of you just have it on Kami. Some of you just have it in a tab. It's up to you. So I'll give you a couple of minutes. Okay, is everyone good on their notes? Someone said your notebook fell under your bed. Are you good? Did you get it back? Yes, no? Uh-oh. You got it. Okay, good, good. All right, so start talking about this. Okay, polynomial functions. First of all, what's a polynomial function? Well, it's just a function that's a polynomial. And it's in the form of, you'll see f of x, right? For those of you that forget, f of x is scary to some of you. Some of you look at this and say, Mister, I've never understood what that means. All this means is if you think of input and output. Remember back in elementary school, you started with input-output tables. When you input something into a machine, something outputs. When I input a 5, 10 comes out. Okay? Then you input a 6, 12 comes out. When you input a 7, 14 comes out. So what's happening from input to output? So I want to do a little quick explanation of f of x and functions because some of you are still questioning what the heck's going on. So can anyone tell me what's happening with this input-output machine that I'm just doing right now? If I input an 8, 16 comes out. So what's happening? You're multiplying by 2. So the thing that's happening is multiply by 2. There you go. And that was the elementary school way of doing this. You just say input, output. This multiply by 2 is the function. That's what's happening to my input. So when you got older, you didn't call it input and output. You called it x and y. My x is 5, my y is 10. My x is 6, my y is 12. My x is 7, my y is 14. My x is 8, my y is 16. Okay, and then you got a little fancier and said, okay, I have an x, which is still my input. This is still my input, right? We still call it an input, but we just get a little fancier, call it x. And then my output is just my function of x. right? What is the function? The function is just what's happening to x, what's happening to the input to get the output. That's all that means. That's all f of x means. That f just means, that's just the name of the function. The name of the function is x. You can call it g, h, w, doesn't matter. But we call it f of x because we're doing something to x. We're doing a function to the input. So the f of x, the function I did to that input, is my output. So basically this is still just my output. So that's all f of x means. It means I got an input x, and I did something to it. In this case, the thing you did to it was multiply by 2. In this case right here is a more complex thing you're doing to the input. So what are you doing to the input? You're doing all this stuff. Okay? So that's all f of x means. It just means I have a function, and function has other definitions too, other things it has to do, but for right now, function means you're doing something to an input to get an output. So f of x is your output. F of x is your y. F of x is your output. It's just your function, just you put f of x because you're doing something to your input. You're doing a function. And all a function means is what the thing you're doing, your rule. That's it. That's all that means. It looks more complicated. And I know a lot of you are scared of that and still are like, I didn't understand what f of x means. That's all it means. Okay? So a polynomial function we have here, it looks very, very complicated, right? So basically what you see here, let me explain the pieces that you see here, is you have a bunch of terms added to each other. That's it. So that's all this is. So you have this term plus this term plus this term, and then dot, 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 dot. And then we go to the second to last term or third to last term, and then we go to another one, this term, and then, oops, what's going on with my pen? And then we have a sub 0, right? So basically, these are just my coefficients. These are just the numbers in front of my x, and then I have x to the n, that means x to the 10th, whatever the n is. I can have x to whatever number. And then the next one is one lower. That's why it says x to the n minus 1, because like if this is 10, this would be 9, this would be 8, and so on. We're just putting it in order, right? That's why it says x to the n minus 2, because it's just 2 lower than, 2 lower than what you started with, okay? And then all the way over here to x squared, then x to the first, and then just your constant. Okay, everyone good? Okay, so that's just a function, a polynomial function. Okay. We just have a bunch of terms added and subtracted to each other, and then all this mess that you see here is just saying I have the a to the n. That's just your coefficient, right? All these numbers in front of the x are just your coefficients, right? All the x's are just x to a certain power, and it goes down by 1 every time you go. Okay, and we're just adding them together. Okay, a to the n at the beginning, you guys see a to the n at the beginning? That's just called, when you see that number right here, that's just called your leading coefficient. Okay, that's your leading coefficient. Okay. And the highest exponent is called your degree. Remember we talked about that before? The highest exponent is the degree of your polynomial. So we're going to stop here for now. It's very blurry. It might be my internet. You can watch the video later. It'll be super clear. It'll be in 4K. So if it's super blurry, you can come back. So hopefully tomorrow it's not as blurry. Maybe the internet's being affected by the rain. I don't know, because on my end it looks clear. If it's blurry to you, it could be both of our internets. Yeah, I record these all the time, and I put them on I put the links in there, and it's we have a YouTube channel. So remember I asked you to subscribe because we're trying to get to 1,000 subscribers. We're at 350 something right now. Yeah, so I record these, and you were able to unmute yourself? Oh, were you saying something when I left to go get my mail? Uh-oh. When did you unmute? When did you say something? I think that I didn't start recording till after. I think you said something during the warm-up. I didn't record that part. I only record the actual lesson. So we're going to stop here because it's 11:42 and class ends in 2.5 minutes. So if it's pretty blurry, you can go back and copy these down from the video that I'm going to put up. I'm going to put it up right after class. And we'll continue tomorrow to talk about looking at these functions and talking about the degree and the leading coefficient. Then we're going to talk about parent functions and the end behavior. The end behavior. And we'll talk about what that is, okay? All right, so if you don't have any questions, I will see you all tomorrow. Have a great rest of your Wednesday. Today looks like a Netflix watching day. Well, do your homework kind of day too, but yeah, with the rain and the cold. So everyone take care, stay dry, and have a great day. See ya.